Okay, so in this video, we're going to talk about solving absolute value equations and absolute value inequalities. So first, let's talk about equations, right? So equations obviously have equal signs. If you'll literally just follow this four-step process, that's all you're going to really have to do. Okay, so first, identify the absolute value expression. Okay, we know that that's just the absolute value of x. Then we isolate that expression. So to isolate it, we're just going to divide by 2 on both sides. And therefore, the absolute value of x equals 4. Then we need to establish what the solutions are. So what this is going to mean, right, is that because it's the absolute value of x equal to 4, that means that x will be 4, but also negative x will be 4. Okay, so obviously one of our solutions is 4, it's just positive 4, but the other one, right, would be negative x equals 4, so we have to multiply by negative 1 on both sides, and we get that x is also negative 4. So we say, right, that x is 4 or x is negative 4, right? And the way we express, so that's us expressing it algebraically, but we need to express it graphically. So graphically is just going to literally be a graph, right? And if we're saying absolute value of 4, well, there's two numbers that have that, obviously, right? One is positive 4, has an absolute value of 4. That's the distance from 0 to 4. Okay, the other is going to be negative 4. That also still has a distance of 4. Okay, so some more gnarly examples, and I see that there's some stuff on here that I didn't erase. Okay, so still following the same process, right? We establish, well, what is the absolute value expression? Then we isolate it. So I'm going to do plus 5, then divide by 2. So when I do that, so I'm going to do plus 5, that of course becomes a 6. 6 divided by 2 is going to be a 3. So I end up with the absolute value of x minus 1 equals 3. Okay, then I establish the solutions. Okay, so this is going to work much the same way as it did previously, right? I'm going to have basically an or statement. Okay, so I'm going to say that x minus 1 is going to be equal to 3, or negative x minus 1 is going to be equal to 3. Okay, so that means x is either 4 or x is going to be equal to negative 2. Okay, and then that's us solving and then graphing them on a number line. So positive 4 would be here, negative 2 would be here, 0 would be somewhere in here, and both of my solutions exist at negative 2 or 4, right? So here's some more examples. So I'm going to add 5 to both sides, and therefore x minus 2's absolute value is equal to 14. Then I split it into my or statement here. So I'm going to say x minus 2 is 14, or negative x minus 2 is 14. So over here, x is going to be equal to 16 when we add 2 to both sides, right? Over here, I got to multiply by negative 1 on both sides, so x minus 2 equals negative 14 instead. Then I'm going to add 2 again, and I get x is negative 12. Okay, so that is our or statement. Our picture, therefore, would look like this, with our two solutions being at negative 12 and 16 respectively. Okay, then I guess I should circle what color goes where. Here, I'm going to add 8 to both sides. Okay, and remember that first step is to always try and get that absolute value expression by itself. Then I'm going to divide by 2 on both sides. Okay, now I've got my or statement I can get from this. So x plus 1 equals 2, or negative x plus 1 equals 2. So x obviously is 1, or after I do some quick maths, x is going to be -1, right? So graphically, that's represented very simply, right? Our two solutions are going to be at plus or -1. Okay, next one, a little bit uglier. Okay, so I've got a fraction here, right? So I have two choices. I can multiply everything by 2 now, or I can wait to see what happens if I don't do that. Either way is, going to work. I'll do it both ways just to show you. So I'm going to multiply everything by 2 right now. Okay, so that means distributing a 2 here and here, and obviously also here, right? And I'll do little arrows because that kind of looks like parentheses or something. Okay, so when I distribute it here, it's going to cancel with this 2 because times 2 divided by 2, they're inverses, right? So that leaves me with just absolute value of x minus 3 plus, well, of course, that's going to be 8 is equal to 8 again, right? Subtract 8 from both sides. X minus 3's absolute value is equal to 0. And then I get my or statement, but I'm going to solve it the other way now. So without just multiplying everything by 2. So first, I am going to want to, I didn't mean to do that. First, I'm going to want to do -4 to both sides, right? So now I've got x minus 3's absolute value all over 2 equals 0. Then I multiply by 2 on both sides, right? And we end up with the exact same thing. X minus 3's absolute value still equals 0. Okay, so either way you look at it, it works out the same way. So that means our or statement, forgot to put the 0, that means our or statement is x minus 3 or, oops, what's the matter with me? X minus 3 equals 0 or negative x minus 3 equals 0. Therefore, x is 3 or, well, we can't have -0, can we? If I multiply by -1 here and -1 here, it doesn't really change anything. I still end up with, so -1 times 0 is still going to be 0. Okay, so that means we get x equals 3 both times. So that means this guy has only the one solution. X is equal only to 3. It doesn't have 2. So now we see a case of a word problem, right? So now we're going to see how this can apply to an actual situation, as stupid as this situation is. So I'll give you a second to read that. If you need to, press pause and read it. Otherwise, I'm going to go ahead and dive right in. So the distance that we're wanting to launch is 200 meters, right? And we have a plus or minus 50 meter discrepancy. So if I do plus 50 or minus 50, well, that puts me at negative 150 or positive 250. Not negative 150. That just puts me at 150. I don't know where I got the negative from. Okay, anyway, so you get the idea, right? So 200 minus 50 puts me here. 200 plus 50 puts me here. Okay, so that's our picture representation, right? So now we need an equation, an absolute value equation that represents this situation, right? So if you remember from geometry last year, we had a distance formula wherein we had x1 minus x2's absolute value gives us our distance in one dimension, right? In this case, we kind of twist that a little bit so that we say, well, the distance from here to here or here to here is 50 either way, right? So that means 200, right? That means 200 minus our unknown distance. So we can call this x2, we can call this x1. Okay, so 200 minus that unknown distance, right, would always give us a discrepancy of 50. We're always going to have a distance of 50 there. Okay, so the distance from 200 both to 150 or 250 will always be 50, right? So that said, that brings us to number 2. So this is where we're going to solve it and see if it actually works, right? So if I solve this equation for x, I should get from my two answers 250 or 150. Let's see if it works. So absolute value is already by itself, right? So I can go ahead and split this into my OR statement. So 200 minus x equals 50, or uh, negative 200 minus x equals 50. Either way, right? So here I'm going to subtract 200 from both sides, multiplied by -1, and there it is. We get one solution. That worked. Okay, then I'm going to multiply by -1 on both sides, subtract by 200 on both sides, multiply by -1 on both sides, and there it is. Okay, so we see how it works. Okay, we see that we have an equation that can express how something can, be 50 away in either direction from a target. Okay, so here we've got another example. This example, though, so from here on, we're going to talk about absolute value inequalities, right? And we see that absolute value inequalities are algebraically similar to equations, right? We're going to solve them pretty much the same way. There's one major difference, though, and we'll get to that when we look at the example. But this particular example, so I'll let you pause the screen and look this over. When you have a proposed solution, email that to me, and we'll see if you get extra credit for it or not. Obviously, I'm not going to help you with that. So here's our first example of an absolute value inequality this time. So we're going to get a little review on inequalities. We haven't seen them yet this year, not since Algebra 1. Okay, but we're going to see that it's not really too much different. There's only one key difference, right? So we're still going to want to get the absolute value expression by itself. So first, we're going to subtract 1 on both sides. So absolute value of 2x plus 3 is greater than 5. Okay, now that we've got it by itself, we get our OR statement. 2x plus 3 is greater than 5, or, and so far nothing really has changed, negative 2x plus 3 is greater than 5. Okay, so here we're going to just still do algebra, get x by itself. So we're going to do minus 3, and then we're going to divide by 2 after that. So x is going to be greater than 1, right? Because 5 minus 3 is 2. 2 divided by 2, right, is going to give us 1 after that. Okay, so then over here, right, this is where it's going to get different. So to get rid of this minus, I'm going to multiply by -1 on both sides. Okay, so when I multiply an inequality by a negative on both sides, when I've got that kind of a sign change, that means this symbol greater than has to flip around. Okay, so what that's going to become is 2x plus 3. The sign change makes us less than now. Less than -5. Okay, because 5 times -1 is -5. Okay, so then minus 3. 2x is less than -8, divide by 2, x is less than -4. Okay, so then what is this going to look like graphically? So let's say 0 is here, right? We've got +1 sitting here, and then we've got -4 sitting out here. Okay, so x is greater than 1, right? So that means we're not including, x cannot be equal to 1, so we're not including 1. So we go back over here, right? And we see we were using these closed circles here to represent our solutions graphically. But here we're saying greater than, so that means we're not equal to that particular solution. So open circle, and x is greater than 1, so that means x is everything to the right of 1. So we would shade, right, just to show that x can be all of this here to the right of 1, but it cannot be equal to 1 itself, right? Then same idea here, and I don't know why I put an equal to sign. I don't know where I got that from. Yeah, just don't erase the one line. But we know that x is less than -4, right? So that means x can be everything to the left of negative 4, but of course we are not including negative 4 because it's not equal to negative 4. Right? So x can be everything to the left of negative 4, but not negative 4 itself. Okay, let's look at another example. So again, isolate the absolute value. So we're going to have 3x minus 1's absolute value is less than 2 because we subtracted 5 from both sides. Okay, so now that it's by itself, we have our OR statement. So 3x minus 1 is less than 2, or 3x minus 1 is, negative 3x minus 1 is less than 2. Okay, so here we're just going to add 1 to both sides. 3x is less than 3, right? Divide by 3, x is less than 1. Okay, over here, multiply by negative 1 on both sides. 3x minus 1 is greater than negative 2, right? Then we're going to add 1 to both sides. 3x is greater than 1, negative 1. And divide by 3 on both sides. X is greater than negative, 1 over 3. Okay? And forgot to mention, right, because I multiplied by negative on both sides, that flips our symbol. Okay, so there's my two prospective solutions. The way I graph it, I'm just going to say negative 1/3 is here, right? And I'm going to say positive 1 is here. And we're going to use an open circle, right? Because we're being non-inclusive with the less than or the greater than symbol, right? And open circle here. X is less than 1, so that means to the left of 1. Right? And x is greater than negative 1/3, so that means to the right of 1/3. So we see that our solution area rather, is here in this area, of course, excluding the two endpoints. Okay. Some more examples just to make sure that we've got it. We would divide by 6 on both sides. Then we split into our OR statement. X minus 2 is greater than 3, or negative x minus 2 is greater than 3. Add 2 to both sides. X is greater than 5. X minus 2 is less than now because we would multiply and flip the symbol. Multiply by negative 1, I mean. So that would become negative 3. Okay, so then we're going to do plus 2 again. So x is less than negative 1. Okay, so then how are we going to graph it? So 5 would go here, negative 1 would go here. X is greater than 5. So that means open circle, and we would shade right. And x is less than negative 1, so that means to the left, right? The left of negative 1. And we would shade left. Okay, I'm going to multiply everything by 3 to get rid of these denominators of 3. Right? You don't have to do that, but that'd be the simplest way to do it unless you're just cool with dealing with fractions. Right? So that's what I would do. So if I multiply everything by 3, that leaves me with just x plus 2's absolute value minus 3 is less than or equal to negative 1. Right? If I didn't do that, I would add 1 to both sides. Right? So this is an option you have. And I would have x plus 2's absolute value all over 3 is less than or equal to 2/3. Okay, then I would still multiply everything by, 3. So x plus 2's absolute value is less than or equal to 2 now. Over here, if I do plus 3, well, guess what I'm still going to end up with? X plus 2's absolute value is less than or equal to 2. So I get the same thing either way that I do it. Okay? So matter of preference. Either way, though, here is our OR statement. X plus 2 is less than or equal to 2. Or x plus 2, the negative of that, is less than or equal to 2. Subtract 2 on both sides, x is less than or equal to 0, or x plus 2 is greater than or equal to negative 2. Had to flip the symbol because we multiplied by a negative on both sides, right? And then do minus 2, x is greater than or equal to negative 4 now. And then our picture, of course, so here's, let's say 0 is there, negative 4 is here, right? And now we're saying x is less than or equal to 0, so or equal to. So now we would include the endpoint. So that's going to be a closed circle. And we're going to shade left because we're saying equal to or less than. And then same thing here with negative 4, but we're going to shade to the right because we're saying equal to or greater than. So that would be our solution area there. Okay. Last example, so minus 1 to both sides. Okay, now we have our or statement, 5x minus 2 is greater than or equal to 3, or 5x minus 2, the negative of that, is greater than or equal to 3. So I'm going to add 2. Okay, then divide by 5, and I've got it. Here I'm going to multiply by negative 1 both sides, so that flips the symbol, changes the sign of everything. Okay, then I'm going to add 2 still. And then I'm going to divide by 5. And there's my other solution. Okay, so then graphically, that is going to look like this here. So this would be negative 1/5. This would be positive 1. And we're saying greater than or equal to 1. So that would be equal to, and then to the right of 1. Right? And then same idea here with negative 5, except we're going to go to the left. So we're saying equal to or to the left of negative 1/5. Right? So that's all I got for this video. Obviously, any questions, let me know. Make sure and email me that extra credit if you have it done. Goodbye.